In the video of Christian and Rahul doing a jump shot, they are showing an example of Newton's first law of motion. Newton's first law of motion states that an object in motion will remain in motion until acted upon by another force. In a jump shot, the ball is in motion, and the ball will remain in motion until it hits the backboard or the rim of the basket. The ball thrown up in the air will keep moving upwards until the force of gravity causes it to descend. As you watch Christian playing basketball with his friend, you are watching Newton's second law of motion. Newton's second law of motion states that objects accelerate according to their mass and net force. What this means is that the greater the mass of the object being accelerated, the greater the force is needed to accelerate the object. While Christian is taller than his friend, he has a greater mass, meaning that he needs to use more force to have the same amount of acceleration as his friend. And vice versa, Christian's friend is smaller than him, so his mass is less, which means he uses less force to have that amount of acceleration. Physics is used in the game of basketball. Newton's second law of motion is very evident with acceleration. Each player uses different levels of force according to their mass to get the results they want. The formula used for the second law of motion is force net equals mass times acceleration. To find the force net in our project, we have to multiply the mass of the basketball times acceleration. The mass of the basketball is 652 grams, and the acceleration is 9.8 meters per second squared. The force net should be 6,389.6 joules. Newton's third law of motion is evident in basketball through the unpredictable act of rebounding. The third law states that every action has an equal and opposite reaction. When the basketball hits the rim, it immediately bounces off in a consistent manner with its velocity. The ball in motion is the action, and rebounding off the rim is the opposite reaction. Newton's laws of motions are not just dunking, shooting, and rebounding off the rim. They can be seen in the player as well. The second law, which relates to dunking, depends on whether or not the player can exert the force in the jump to be able to dunk. If a player does not accelerate enough, then he or she may not be able to reach the rim, restricting them from dunking. It is impossible to significantly reduce your body mass in a matter of seconds. So a great basketball player needs to be able to control the amount of force and acceleration they give off to get the results they desire.